Another type of problem that you might see is one about consecutive numbers or consecutive integers. A lot of times we say. Um, so what does consecutive mean? Well, they are numbers in order. So nothing to be too complicated, but like if I start at 18, 19, 20, 21, those are all consecutive numbers. But also see that there's a phrase here, consecutive even numbers and consecutive odd numbers. So examples of consecutive evens could be like 28. Then you would go to 30, 32, 34. Okay, those are consecutive evens, and then you might be able to imagine consecutive odds. I don't know, let's go 3, 5, 7, 9. Okay, those are just some examples of consecutive numbers. Technically, this is our example of consecutive numbers, and then we have consecutive evens, consecutive odds. Now, I purposely wrote those up there and left blanks in here because we can represent any consecutive numbers as long as we have our first number, and it's an unknown, so let's just call it n. Then the next number, so the consecutive number after it, the next integer is one more. So we could write it as n plus 1. The next one after that is one more than that. So n plus 2, n plus 3, n plus 4, and you can keep going on with that, as long as you have that very first number. Okay, consecutive even integers. Very similar. You start off with the first even number, so n is some even number here, but you don't add 1, you skip the odd that's in between, and to get to that next even number, you add 2. And you have to add 2 again, so adding 2 to that plus 2 already is actually plus 4. N plus 6, n plus 8, and so on. And with odds, it's very similar to even numbers, except the starting number, I'll still have it as n, but now I just have to know that n is some odd number. But I have to add 2 to it to get to the next odd number because I want to skip the evens. And actually, you find that we get the exact same pattern, at least in the formula sense. Again, like I said, the difference is the first number is odd instead of even. All right, now this we can write equations with this knowledge. So the sum, that means addition, remember, of two consecutive numbers, so we're talking just consecutive numbers, like up here, is 123. So is equals. So two consecutive numbers. Well, we have to have the first one, which is, we'll just call it n. N's the first number. And the sum, we're going to add the next number, n plus 1. And that is 123. So there we go. We've got an equation. I put that n plus 1 in parentheses just so I kind of make that stand out as the second number. But now when we're starting to solve this and we want to solve for n, and that'll help us find the two numbers. So what we'll do is we'll find the smallest number and then we'll find the one that's a little bigger. So we could rewrite this. This is 1n, and this is all addition. So those parentheses really aren't doing much here, so we can drop them. And we have another 1n plus 1 equals 123. And you might notice we have like terms. 1n plus 1n, that can become something. Let's continue over here. 1n plus 1n is 2n plus 1 equals 123 still. And we can solve. Subtract 1 from both sides. The 1's cancel. Then 2n is now equal to what? 122. And that's multiplication, so we divide. Cancel. Keep that going over here. What is that going to be? N equals 61. n equals 61. And remember, we had said at the beginning, n is the smaller value. It's the first one. The next one is n plus 1. So what's 1 more than 61? It's 62. So our answer is 61 and 62. When you have more than one answer like that, you can present it in a solution set, which is those braces. All right, now this next one. We have 3 consecutive even numbers, and we're still doing sum. But now we're having the sum of 3 things. So it'll be one thing plus another thing plus another thing, and that is equals 138. Now, what are these things? Well, we kind of written it up above. The first number is just n, or whatever variable you want to use. I'm just kind of in the zone with n's here. The next even number is 2 more than that n, so n plus 2. And the next even number after that is 2 more again, so n plus 4. And there we go. And just like that last one, all of those n's have a coefficient of 1. So when we combine all the n's together, 1n plus 1n plus 1n makes 3n. And notice we also have constant terms that we can combine here. 4 and 2, those add up to 6. So 3n plus 6 is equal to 138 still. And we have the two-step equation. You might have noticed that this has been coming up a lot. It's pretty common. Most equations end up with a two-step equation. That's going to be 132 after that subtraction. And divide by 3. What is that going to be? N equals 44, I think. Yeah, 44. So that's the first. Remember, though, we're looking for these 3 consecutive even numbers. 44 is the smallest one. Then you go up to 46 and 48. All right, the last set, just some other word problems, I suppose. And just to give you guys a nice wide range of different equations that you can check out, different stories, word problems. So here, this one's really pretty basic, the actual problem. We have 2 equations. They're y equals 3x minus 7 and y equals 9x plus 17. The question says, for what x value will the y values be equal? So the x value is what we're looking for, but we don't have to come up with a variable. They're kind of telling us the variable is x already. So we're solving for x eventually. And a clue here is that the y values are going to be equal. So we want these 2 y's to be the same or equal to each other. And what we can do, we kind of did this with that perimeter problem where L was equal to something and we were able to plug it in. But on this first equation, y equals this stuff, right? All that stuff. On the second equation, y equals all of this stuff. And if those y's are the same, then what they're equal to is also the same. And that's actually a property we learned a little bit a while ago. The transitive property, remember, it goes like this. If A equals C and if B equals C, so they both equal C, some very other number, then we would also be able to say that A is equal to B. Right? That's the transitive property. So anyway, in this case, what we can set equal to is the green and the blue stuff that I circled. So it'll be 3x minus 7 equals 9x plus 17. And we've got variables on both sides of the equal sign. So our first step, well, first off, we should see if we can simplify either side. But there's no distributing that can be done because there's no parentheses. And we can't combine like terms because everything on the left, 3x and negative 7, they're not like terms. On the right, 9x, 17, they're not like terms. Okay, so we need to cancel one of the x terms. And I'm going to go with the 3x by subtracting, because that's a positive 3x. And then that'll cancel here. That'll leave me with a negative 7 equals 6 now. 6x. And now we can solve a two-step equation. So take care of the addition by subtracting. Do that to both sides. What is that? Negative 7 minus 17 can be tricky. That equals negative 24. And 6x. And then that's multiplication. To cancel it, we divide. Negative 24 divided by 6 is negative 4 equals x. So there you go. So negative 4 is the x value that will make the y values equal to each other. And you could check this by plugging negative 4 back in for the x on each, and it will work out. I believe it's negative 19 for each once you plug it in, because it's 3 times negative 4 is, that'd be negative 12. Negative 12 then minus 7 is negative 19. Over here, 9 times negative 4 is negative 36. Negative 36 plus 17 also gets us the negative 19. All right, let's take a look at this containers problem. There are two containers of water. Container A has 1,000 milliliters of water, and container B has 200 milliliters of water. At the same moment, container A starts to drain at 6 milliliters of water per second, while container B fills at 18 milliliters per second. How long will it take for the containers to hold the same amount of water? All right. So as I was even reading that, I kind of am getting these images in my mind. So I want to write them down, okay? So I think drawing a picture is a good call in this problem. So let's call this container A. And it's got, well, let's get some color going in here. It's got 1,000, let's say that's 1,000 milliliters of water right there. All right, and we also have container B, but it does not have as much water. It's only got 200 milliliters of water. But we have some difference. Oh, that's container B. We have some differences here. Container A, so at the same moment, so these are happening at the same time. So maybe it's got like a spout or something. The water is draining out, right? Flowing out at 6 milliliters per second. Per is, you can do a slash like that. Okay, and here, I don't know, maybe we've got some sort of hose. Okay, filling it up here from a water can, I don't know. Okay, and that's filling it up at, what is it, 18. We're gaining 18 milliliters. Filling it up, so this water level is rising. Okay. So, and those are happening at the same time. So the fact that we're gaining 18 milliliters over here, I think of adding that on, okay? Oh, and that's happening per second as well. And the fact that we're losing 6 milliliters per second, we're going to be subtracting that off on that side. And we would like it, there's some magical spot, probably somewhere a little lower than 1,000, or I don't know if it's going to be a little, but lower than 1,000, and also above 200. We want these to be the same height, okay? So we want them to be equal. Now, what is the unknown in all of this? The question asks how long. So how long? That's a time thing. And the time that we see here is seconds, right? Because it's saying that per second. So let's call X. X can stand for the number of seconds. All right. So let's start off with container A. So that's, we've got 1,000 milliliters, but we want to subtract off this 6 milliliters per second, or for every second. And we know that seconds stands for X. So we're actually going to subtract off 6X, 6 times every second, because for every second we're losing 6 milliliters. And that's going to be equal to 200 is the starting spot for B, but we're adding on 18 milliliters per second. So adding on 18 times X. And here we go. Now we've got an equation. We can solve for X. We've got variables on both sides again. You can cancel out the -6 or the +18. Either way is fine. The way I see it is it's easier to cancel with addition. It's just a little mentally a little nicer to add, I feel. But yeah, so these cancel, and now I'm still left with 1,000 on that left side. 200 plus 18x plus 6x is 24x. And we want to now solve for x. We've got 24 being multiplied, 200 being added. It's a positive 200, so I'm going to subtract that. We'll save that division for the last step. 1,000 minus 200 is 800. Now, let's go ahead and do that divide step, which cancels here. And 800 divided by 24 is equal to 33.3 repeating. Okay, it's a repeating 3. So when we're actually giving our answer, we probably wouldn't worry so much about the repeating 3 and stating that in our answer. So I would say it's about or approximate, but I'll say about 33.3, and the label here is seconds. So it's not going to take too long for them to get to the exact same height of water, because remember, that's what the whole thing was. We're trying to find out how long does it take for those containers to get to the same height. And it'll be just under 30, or just over 33 seconds. And there will be a Delta Math assignment with this. Come back to this for reference and for help. Reach out to me with any questions you might have. Good luck.